Greetings and welcome, friends. Mr. Waddy here. We're taking a look at last night's quest. Hopefully you did this quest. If not, follow along, and I can still help you out. Because we're prepping for a test today, those of us in real life here. So as far as this goes, we had a new form, Intercept Form, which was y or f of x equals a parentheses x minus p times x minus q. A was able to tell us whether it opened up or down. A still gave us the slopes, which is super helpful. So A was allowing us to determine our slopes. And do you guys remember what P and Q informed us of? Are the X Intercepts. All right, X Intercepts. So here we go. For this first problem, it says find the X Intercepts, and this is just reading it off the graph. So the X Intercepts is where the parabola crosses the graph. So it looks like it crosses at 2 and 5. So X int are at 2 and 5. And the axis of symmetry is actually going to be halfway between those. That was the other thing that we realized, right, is that halfway between those points will be the axis of symmetry, or H, right? H was equal to P plus Q divided by 2, right? The average, add them up, divide by how many there are. So H is equal to 2 plus 5 over 2. H is equal to 7 over 2, right, which is 3.5. So the axis of symmetry here is x equals 3.5 is what that ends up being. So 3.5 is where it crosses, and that makes sense because parabolas are mirrors over each other. Their x intercepts will also be mirrors of one another over the x axis of symmetry. Sorry. So let's get to graphing a problem. All right, so here we go. Let's start by labeling A, P, and Q. So A is going to be -1 here, like so. P is going to be 6. No, -6. I forgot. It's the opposite of that, remember? And Q is going to be +4 because it's the opposite of that. So if I graph this, I can't quite see my grid that well. Here's -6 for one of my x-intercepts. Here's +4 for the other x-intercept. Wait a minute, guys. I don't think our graph has... It's -1. I gave us a graph that will not be helpful. Wait a minute. It's opening down, and I'm not going to be... Oh, okay. All right, my bad. All right. Whew. I was thinking opening down, but that means the vertex would have to be above this. Crazy, Mr. Waddy. Crazy, Mr. Waddy. All right. I was doubting myself, but my past self, high five, represent. So H is going to equal P plus Q divided by 2. So -6 plus 4 all over 2. H is going to equal -2 divided by 2. I end up getting H equals -1. That's also going to inform me of the axis of symmetry, which will be x equals -1, an equation. So the axis of symmetry is not just like a number, it is, right, the equation of a vertical line, and it's going to be halfway between that. Now, we talked about the fact that there are technically infinitely many parabolas that have those x-intercepts and this axis of symmetry, right, depending on how steep the slopes are. So it would be good for me to find what is the y-coordinate of the vertex, what's the k, and I can actually use my same old approach. K is just going to be f of h, sorry. So k is going to be, what do I get when I plug -1 in for the x's here? So that's going to be -1 times, right, these two things. So -1 plus 6 and -1 minus 4. So I'm going to have k equals -1 times -1 plus 6 is 5. -1 minus 4 is -5. So it looks like -5 times -5, which will be +25 for the value of k. That means my vertex is at -1, 25. So -1 up 25 conveniently. Past Mr. Waddy did graph this correctly. Whew! All right. A, tell me, which way does this open? Opens down because A is negative, right? So I can determine that. I can also figure out the slopes. Let's do that. I think I've got space down here. Sloppy slopes. So it's normally up 1, over 1, up 3, over 1, up 5, over 1. And I'm going to multiply those numerators by the A, the -1 here. All right, so it's going to go down 1 over 1, down 3 over 1, down 5 over 1. So let's see if that works out for us. Down 1. Our test is going to be all of chapter 8.1 to 8.5 today. So down 1 over 1 brings me down to 24. Down 3 over 1 will bring me down to 21. Down 5 over 1 will bring me down to 16. Down 7 over 1 will bring me down, oh, sorry. Here we go. I plotted that point. I shouldn't have. There it is. Let me actually unplot that point. There we go. Right, so I'm at 16. The next odd number is 7. Down 7 from 16 brings me down to 9 over 1. And then what's the next odd number after 7? 9. And that conveniently lines up with where that was. So I can actually now mirror these points if I want over the axis. So that was 1 away, so 1 away to the left. This is 2 to the right, so 2 to the left over here. This one is 3 to the right, so 3 to the left over here. Let's see, it looks like right there. And this is 4 to the right, so 4 to the left at 9 right there. And wow, this is going to be a lovely parabola. We don't normally have all of these points. And then I messed up, but that's okay. The points matter to me more than your ability to draw a smooth curve. Okay, so so let's see, domain and range it did ask about. Regarding domain, I guess I can fit that down here. The domain is everything. It's just that everybody, all right? I could plug in -1 million, I could plug in +1 billion, it doesn't matter. The range, however, it never gets higher than its highest point. Yeah, what is its highest point? 25. So the range is going to be all y values less than 25. So I'm going to say the set of all y such that y is less than, or equal actually in this case, 25. So there we go. There's a domain and a range. All right, so lots going on with this, but notice I only had to plug in 1 point. It's not like I had to make a whole table of values here. And I was able to just use our knowledge about parabolas and their shape to be able to figure out most of this graph. So that's not bad. Let's see. Let me do this one last one real quick. Everything less than 25. Less than or equal to 25. Yeah, I'll show you back at the end because we get the test today. I want to quickly get going here. So let's see, h of x equals, I want to factor this so it's in intercepts form. So I'll have -5 parentheses x minus, no, 1. No, x, what am I doing? Blah. All right. Okay. All right, wait. Mr. Waddy is sleepy today. So I'm going to factor out the 5, right? And I'll have x squared to the -5, so it would be x squared minus x. Huh. Do I want to factor out the x? I do. Okay, this is actually, aha, I do. Here we go. My bad, my bad. -5x. And then I'll show you how to represent that. This one is different. and I'd be left with on the inside x minus 1. Now, as far as intercepts form, I want to point this out. This is written as the product of three things. Yeah. So I'll have -5. This x, watch this x. I'm going to expand this. Here, let's, I'll pick this color here, I guess. I'm going to expand this x to being this. You'll see what I'm doing here. X is the same as x minus 0. Would you guys agree? Yeah. And it's kind of weird writing it that way, but it might be helpful for me to find the P and the Q. All right, we didn't see one of those yesterday, so this one is a little different. So I'm going to have h of x equals, oh wait, yeah, I've got it. I don't need to rewrite it. So a is equal to -5. P is equal to 0. And Q is equal to +1. So here's 0. Here's +1 for those intercepts. Today, no. Let's see, we can find H using the average of P and Q. Oh, this one's going to be a weird one indeed. So 0 plus 1 divided by 2, right? Yeah. So that's going to be a half. So there's H. That's also going to determine our axis of symmetry. So it's x equals a half. So that's a little weird. That means at the half tick mark, I've got this. Did I not expand this enough? No. This will be fine. This will be fine, I think. Yeah. Will it? We'll see. All right. And let's find the value of k. And k is just going to be f of h, right? So I'm going to plug in a half into the function. That's going to be a little bit weird for us, but that's fine because we've got fractions. So k is going to equal, I guess I'll plug it in this form. So it'll be -5 times a half minus 1. A little bit of fraction work here. -5 times a half is -5 halves. And multiplying that by a half minus 1 is going to be -1 half. And so I'm going to have k is equal to +5 fourths, which is 1.25. Yeah, this one is weird. So the vertex is at, I'll call h 0.5 if you want, and 1.25 for k. So over a half and then up. Man, I can't even see my grid. Let's zoom in and see if it shows up any better. There we go. All right, so there's 1, there's 2. So up 1 1/4 is roughly there. Now, what's really tricky is, because this landed so funny, I might end up changing my grid next time. Yeah. The slopes are going to be -5 times 1 over 1, -5 times 3 over 1, and -5 times 5 over 1. And so that's going to be down 5 over 1, down 15. Yeah, so this is a tricky problem because it ends up landing on so many of these weird points. So let's see if I can plot this. So from 1 1/4, I'm going to go down 5. All right, so that would 1 would bring me to 1/4. This would bring me to -0.75 for when I'm going down 2. Then 3 would be -1.75. 4 would be -2.75. Down 5 would be when I get down to -3.75. All right, so moving on these amounts is definitely weird. And then over 1, I'm at a half mark, so I've got to go over 1, so I'm going to land over here. Yeah, so it's definitely weird, right? So I'm 1 unit away from this half mark. Mirror that is going to land me right here. Right, so being able to move by that and then going down 15 from here, like I said, yeah, this is definitely a little bit bizarre. So I'm at negative 3.75 minus 15 is going to be bringing me down to negative 18.75. Oh. Negative 18.75 over 1. Yeah, so it's weird when you've got decimals. I think I've got friendlier stuff for you guys on our test today. Right, so it's tricky. It's tricky. So it does work out. It's just weird because we had a decimal y-intercept and a decimal, right? Sorry, a decimal vertex. There we go. All right. Well, thanks for watching, internet friends. Have a good day.